Okay, Assalamualaikum warahmatullahi wabarakatuh and very good day to everyone. So today we from Group 7 would like to present about our integrated design project, the flood detection and avoidance system. So this is the group member of Group 7. We have Aina, Hiyama, Kah Meng, Mama Aiman and myself, Mama Iskandar. So next I will move on with the introduction for the project. So this is the background about flood, which is the theme of our project. All this data is obtained from the Department of Irrigation and Drainage of Malaysia. We have the definition, the types and the cause of flood, and also on the right hand side we have the map of Malaysia with area prone to flood. So for anybody interested with the information, you can scan the QR code at the bottom right corner of the screen to visit the website of the department for more information. Next we will move on with the problem statement. So as we know that flood is one of major disaster in Malaysia and a lot of problem comes with flood. So the first problem that we have the existence of multiple variables contributing to flood risk, which is the high water level and also high water flow rate. So we need a method to detect and measure flood risk, and also how do we notify people about the situation. So based on the problem statement just now, the objective of our project is firstly we want to design a system that can measure and quantify the flood risk, and also then we want to notify the citizen on the impending flood risk, and also we want to improve people preparation for potential flood disaster as a whole. So next, why do we need this project is because, as explained earlier, the green part of the map shown on the right is actually area prone to flood. Flood occur at this part of the Malaysia almost every year, and a lot of loss is suffered by the country as a result from flood. So this project is very much needed. So this is the approach that we used in designing the project. Firstly, we want to collect the data using sensors, and then we share them through Internet of Things platform to a mobile app, and then we have a warning or notification system to let people know about the situation, and also we have a mechanism to expel excess water from the system. So this part will be further explained later on in the technical part. Next, we move on with the benefit. Firstly, it's save cost because we use the project doesn't cost a lot. Okay, next we have convenience because the project use mobile app as a medium to receive information, and also we can monitor data in real time so we can know of the risk at any time. Alright, so next we have the available commercial product. So we have the application by Meteorology Department of Malaysia, which is My Cuaca, which can pretty much have the same functionality as our project. It can warn people about disaster and also have the GPS tracking functionality. Next, the significance of our project. Our project is very important because people need information in order to act. For example, even the organization that's responsible, such as the MCDF, needs information before they can take action. So this project can potentially save lives and improve preparation for the flood. So next, I will pass the technical part for my teammate Aina Hiyama to present about the part. Thank you.
My name is Aina Hiyama. I'm going to present the components used in this project. The first one is ESP32. It is the main board that controls the whole system. And these are the sensors: ultrasonic sensor, water flow sensor, and GPS module. The ultrasonic sensor is to sense the water level of and water flow sensor is to sense the water flow, and GPS module is to sense the location of the sensors. And this sensor will constantly collect the data every 1 second. And this LED and buzzer are alarming component. This LED and buzzer will turn on when the situation becomes critical or dangerous to tell people not to come near the place that dangerous. And solenoid valve is to control the water level. When the water level becomes too high, it will open the valve and let the water flow to other place so that the water level will be low again. And then this is the smartphone app. This is where user can see the live stream data of water level and water flow. From here, user can decide the action to taken. based on situation of the water level and water flow. So this is the design. PVC pipe is the main structure of this project, and then the ultrasonic sensor is to sense the water level in this way, and water flow sensor is to sense the water flow in this way. And ESP32 controller box is outside the drain, and also there is LED and buzzer to tell the people around that the situation is dangerous or not. GPS module is inside the box too. And for the system flow, first when we start, we connect the ESP32 to the internet and display the real-time data on the app. The data consists of this data, and this system is also constantly checked whether the water level and water flow is high or not. If it is high, it will send warning notification to the phone and also control the valve to open, LED on, buzzer on. And if the water level is not high, it will turn off the notification. It will not send a notification and close the valve of the LED and buzzer. So next part, demonstration will be presented by Aiman.
Hello, so now I will explain about our project prototype. So this is our prototype. At the top of the part, we put a water flow sensor, and then on the right side, as you can see, we have solenoid attached to the water flow sensor. And this is our circuit. There are two parts of our circuit. The first one is main circuit and the second one is for solenoid circuit. The ESP32 and solenoid is powered by my laptop, and the solenoid is powered by the power source. Next, as you can see at the box, we set 3 levels for water level, which is safe level, warning level and critical level. The distance water level sensor from the base is 68 cm, and the distance from the base to the safe level is 8 cm, and safe level to warning level is 9 cm, and warning level to critical level is 9 cm. Next, I will show you how our project works. First, we must add the alternate code that we get from the Blink app to the Arduino. And second, we must set a SSID and the password that we want to use to the Arduino. And then we press upload button at the Arduino while all the component is connected. Then we go to our mobile phone, and then we turn on the mobile hotspot, and if the hotspot show device connected, and we are ready to go. And number 5, we add water until the safe level, and then as we can see at the Blink app, it shows that the current level of water is 9, so it is safe level. Next, then we add water until warning level. So we saw this at the Blink app, it showed 18, so it 18 cm. And then we get a notification water level high is pop out at the phone. So that meaning meaning when we add the water until this, it show that the water is high and it will give warning to the user. And the second and next we will add until the water is critical level, and this is what we get from the our apps, and it show the current level water is at 25, and after this it will send a notification water level critical at the phone. When the water level is critical, we can see that the LED will blinking and the buzzer will alarm. As you can see this. This is when the water level is critical. Other than that, when the water level is critical, the solenoid valve will open and the water will flow through the water flow sensor when the water level reach critical level. As you can see, the water is flow when the water level is in critical point. That is when the water flow reach critical level. It's same concept as when water level is critical. The LED and the buzzer will also be functioning. And the user also will get a notification that the water flow is currently in critical state. As you can see, the water flow will be critical when it reaches 23. And next is a GPS module. The GPS module show our current location where we simulate our project. So for this example, we simulate our project at Kolej Sajuaya KL. That's all from me, and I will pass to Kah Meng.
I'm Kah Meng, the last member of this group. I will talk about the cost, limitations, and future works for our projects. For the cost, our project total used 335 ringgit for the whole project. There are 5 main components for our project, which are ESP32, solenoid valve, GPS module, water flow sensor, and ultrasonic sensor. Next, I will talk about the limitations for our projects. There are 5 of it. Firstly, the angle of detection of ultrasonic sensor JSN SR04 is too wide. The water flow meter YFS201 is also not waterproof. Besides that, the material of our body of prototype is too light and weak to handle high water flow. Next, the application of solenoid in real-life situation is also not possible as it requires high cost and space consuming. Lastly, our project also requires network or Wi-Fi to receive notifications on our phones. Next, I will talk about the future works for our project. Firstly, we plan to replace the water flow sensor with waterproof water flow sensor. Next, reinforcement of the body of the prototype by using dry pipes. Next, we also plan to add on more types of sensors such as moisture sensor to predict the weather. Lastly, the implementation of video surveillance system on the real-time images. That's all from our group on flood avoidance and prevention system. Thank you.